Alcohols and halogen alkanes. We'll start with question 27. Question 7, the skeletal formula is shown. Skeletal formula of some five carbon halogen alkanes are shown, as you can see. Which of the above halogen alkane is not a structural isomer of the other? To be a structural isomer, they should have the same molecular formula. But that's a definition. And structural isomers can be chain isomers, it can be position isomer, it can be functional group isomer as well. So when we check, this is one carbon here, one carbon here, one carbon here, one carbon here, one carbon. How many hydrogens it will have? This will have one hydrogen because three bonds are shown. This will have two. In a skeletal formula, we show the carbon structure. This will have two hydrogens, this will have two hydrogens, and this will also have two hydrogens. So we count the number of the carbon atoms, the total number of the carbon atoms. So there are five carbon atoms, C5, and hydrogen are 1, 2, 3, 4, 5, 6, 7, 8, 9, C5H9, and Cl is there. What about this one? So we have 1, 2, 3, 4, and 5 carbon. How many hydrogens are there? Because two bonds, so this will have two hydrogen, this will have two hydrogen, this will have two hydrogen, this will not have any hydrogen, and this will have three hydrogen. So this is also C7, C5H9, and then Cl. So that's also correct. Like the same molecular formula. So these two are structural isomers of each other. What about the third one? So we have 1, 2, 3, 4, 5. So this is C5. How many hydrogens are there? So this will have three hydrogen, this will have three hydrogen, this will have one hydrogen, one hydrogen, one hydrogen. So this will become 9, and then Cl is there. The last one, so you have 1, 2, 3, 4, 5 carbon, so C5, hydrogen, 3, 4, 5, 6, 7, 8, 9, 10, 11. So H11 are there and then Cl. So this is D is not the structural isomer. Is it clear? The next we have, which of the above is not a secondary halogenoalkane? Say the term secondary refers to a carbon which is attached with a halogen. If it is surrounded by two alkyl group, we call that as a secondary. If it is surrounded by three alkyl group, we call that as a tertiary. And if it is surrounded by only one alkyl group, we call that as a primary. So we have to check the carbon which is attached with the halogen, how many carbon chains are around. So when we check the carbon attached with a halogen, so this is a carbon attached with a halogen. How many carbon chains are there? How many carbon? 1 and 2. So mean this is a secondary. We want which is not a secondary. When we check this one, the carbon is attached with a halogen. So one carbon chain, two carbon chain, third carbon chain. So this is a tertiary. This is not a secondary, it's a tertiary. And so B is the right answer. But what about C when we check? Carbon is attached with a halogen. How many carbon chains are around? Oh, like 1 and 2. So this is also secondary. And a carbon is attached with a halogen. How many carbon chains are around 2? So this is also secondary. So the structure B is a tertiary halogenoalkane. So we write B. Next is the reaction of a preparation of a propene from one bromopropane is shown below. This reaction is classified as, so how we classify this reaction? We have C3H7Br and it is reacting with NaOH to form C3H6 plus H2O. So the term elimination means when a small, when a usually like when alkenes are formed from these halogenoalkanes and a small molecule is given off, we call them as elimination reaction. So you can see here from a halogenoalkane, the term oxidation means addition of oxygen or the increase in oxidation number. So when you write the oxidation number of each of them in this, you don't find any difference. So it's not oxidation. It's not also substitution. If it was a substitution, then what should happen? If it was C3H7Br and it was reacting with NaOH, so this OH will take position of a Br and a Br take position of OH. So this will become C3H7 OH plus NaBr. That will be, then we count as a substitution when an atom or a group of atom replaces another atom or the group. So this is the elimination reaction. The term elimination is like when alkenes are formed by giving out a small molecule, we call elimination. So that's why A will be the right answer. The molecule shown below is 3-chloro-3-methyl-hexane. It reacts with hot alcoholic potassium hydroxide to produce a number of different alkenes. Which of the following could be produced from 3-chloro-3-methyl-hexane? So we have 3-chloro-3-methyl-hexane and a reaction happen or occur. So what are the reactions of these? This is the elimination reaction. Elimination reaction means in the elimination reaction, it will result in a formation of alkene. So which alkene could be produced here? How we'll identify, like if I draw the structure of this is CH3, CH, C is there. One end is a chlorine attached. One end is a carbon chain, CH2, CH3, CH3, CH2, CH3, like 1, 2, 3. So 1, 2, 3. And then CH2 and CH3. So CH2 and CH3. This is the structure. Now, when the elimination reaction happen or occur, the chlorine will be lost. When the elimination reaction happen or occur, the chlorine will be lost. So this chlorine will be lost, and then what will happen? One of the hydrogen will be lost. Like any of the carbon, like this carbon can lose its hydrogen, this carbon can lose its hydrogen, this carbon can also lose its hydrogen. If the first carbon, because all possible, like this carbon can lose hydrogen, or this can lose hydrogen, or this one can lose hydrogen. So if the first carbon loses hydrogen, so what will the new structure? It will be CH2, double bond, chlorine is being lost. Then CH2, CH2, CH3, CH2, CH3. In exam, you can also draw it as a skeletal formula as well. Like I'm just explaining from a displayed one, but in exam, you can just use a skeletal formula as well to identify what will be the product. Like if this, because the possibility is that this might have a double bond. If this might have a double bond, then what is the name of this compound? We always select the longest carbon chain, and we have to include the double bond in the structure. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. How it is 3-chloro? Because they consider this as a chain. The longest chain is this. That is why it is 3-chloro. 1, 2, 3, 4, 5, 6. Like this is a chain it's considered the longest chain. That's why the name of a compound is 3-chloro. So, but if this electron, this loses the hydrogen, and the chlorine is being lost. So what is the name of this compound? So 1, 2, 3, 4, 5, 6. But we have to include a carbon-carbon double bond. So this is our longest chain now. And this is a branch. So second position, we have a branch. So it is 2. And which branch is there? CH2, CH3. So this will become 2 ethyl. And 1, 2, 3, 4, 5. So for 5, it will be pent and one first. So it will form 2 ethyl pentene. So if the first carbon loses a hydrogen, then the product should be 2 ethyl pentene. But it is not a 2 ethyl pentene. There is no option of 2 ethyl pentene. So we ignore that. Now, the second possibility that maybe this might loses its hydrogen. How do we know which is a major? No, the three possibilities are there. In this one, there is no major or a minor. The three possibilities are there. You have to identify what is the right structure. Because here the halogen, here we have a chlorine. So if the chlorine loses, because in elimination reaction, the adjacent carbon can lose their hydrogen. Like this is CH3, this is CH2, this is also CH2. So either this hydrogen can be lost or hydrogen can be lost here or hydrogen can be lost here. If the first one loses the hydrogen, if this loses the hydrogen, then what should be the name of the compound? If this chlorine is being lost, so the name of the compound will be 2-methyl hex, 2-methyl pentene, because there will be 5 carbon atoms. So 1, 2, 3, 4, 5. So this is will be our longest chain now, and this will be the branch. So this will be 2-methyl pentene. So this is not possible. Then we have, like, this is not the, there's no option of a ethyl. Now what if this one loses electron, the hydrogen, the on the right hand side, if this lost the hydrogen, so there will be double bond here, there will be single bond here, and this is CH2, CH3. We select the longest chain. So what is the 1, 2, 3, 4, 5, 6? So this is the longest chain. Numbering should start from a nearest uh, double bond. First is the priority, the double bond. So if I count from here, it will be 1, 2, 3. So third position, I have a branch in third position. So it will be, this will be 1, this will be 2, this will be 3. So third position, I have a branch. In third position, I have the methyl group. So I can say it is 3-methyl. And 1, 2, 3, 4, 5, 6 are there. So it will be hex because of 6. But the third carbon is having a double bond, so it will be hexene. So it is 3-methyl hexene. 3-methyl hexene is not an option. So means this is not possible. Like this is possible, but this is not the product here. According to the option, it's not given. Then when we remove, if this is losing its hydrogen, then what will be the structure? There will be a double bond here. This will be CH. 4 bonds are already there. So now when we select, so 1, 2, so second position and third position. So this will become 3-methyl hexene. So 3-methyl hexene, so it matches with option C. Because 3-methyl hexene is already given as an option. Is it clear? This is called elimination reaction when halogenoalkane in the presence of a hot alcoholic potassium hydroxide, it produces an alkene. So three different possibilities are there. 3 of the carbon loses, but the name of the product does not matches with the option which were given. So only one it matches with, which was 3-methyl hexene. Which of the following has not been used for a CFC, the chlorofluorocarbon? So CFCs are not used as a fuel. They are used in dry clean solvents as well because and fire retardant, refrigerant, but it's not used. CFC is not used as a fuel. Then butane is an aerosol propellant now used as an alternative to CFCs. Although it is less destructive to ozone layer, it has a disadvantage of being. So what is a disadvantage? So because alkanes are highly flammable, it can catch fire. So it's highly flammable. That's why chlorofluorocarbons are, and it is used butane and aerosol propellant alternative to CFCs. But what is and although it is less destructive to ozone layer, it has a disadvantage of being corrosive. Is refers to when something cause like damage the surface, like it can be skin, it can be metal, it can be any surface. It damage the surface. We call it as corrosive. So these are some questions from you have to memorize these uses for the halogen alkanes, alcohols, carboxylic acid, alkanes, alkenes. So these are some questions from alcohols and halogen and alkanes. Next session we'll do more from different paper.